If I enter the hall, I feel this exciting atmosphere.
You think it's such a beautiful experience to see so much know-how concentrated on such a small space.
And it's unique also. I mean, you can't have it in many, many places, yeah, to bring all these competences together.
And so this piece of machinery is doing something with the scientists, because they sit there and they feel that and they get ideas. And they get crazy ideas. And that's good, I would say. Yeah.
And the synchrotron electrons are flying in a circle very fast, almost at the speed of light.
And then at certain positions, which we call the undulators, they get accelerated to the left and to the right. And with this acceleration, they start to emit X-ray photons.
This light has very specific properties. And these properties of the light we need to understand how our materials work, how the interfaces in the solar cells are designed.
Because it's such a complicated interplay of very large scale and atomic scale know-how, you need all those intricate machines that allow you to watch the processes on the atomic level.
So each and every atom has to be in place.
In the worst case, we could have one atom in a million. If that's the wrong atom, it could really reduce the efficiency of our device with an enormous amount.
So you can imagine everything is comparably tedious.
Our energy source is sunlight, and if you look on a rainbow, the sunlight has different colors. So there's blue light, red light, green light, and our solar cells has to be most efficient. And to achieve this, we have to design our solar cells to this spectrum.
Silicon material absorbs the visible part of the spectrum very good, but in the near-infrared region of the solar spectrum we need to help the silicon somehow. We need to help the silicon to trap the light efficiently, that it can be absorbed and can be converted into energy. We do this light trapping by nanostructuring of our solar cells, and such that the light is scattered into the absorber material and can be converted into energy.
Energy storage is a key issue. To store, for example, during night, this can be done by batteries. We need new types of batteries, but we also need seasonal storage for longer periods, and therefore we need chemical energy storage.
We need to combine the functionalities of a solar cell and an electrolyzer. And our dream is to combine these functionalities in a single material. And this single material we can then immerse in water, shine light on it, and then on one side fuel comes off, hydrogen, and on the other side oxygen comes off. That is what we try to achieve.
For us, it's the difference between knowing that you can make a certain solar cell, so it's a proof of principle, and what we do is a proof of concept. So it means, can we make this record solar cell in such a way that it can be produced economically? And it means, do we have the equipment, do we have the processes, do we have the materials, so that it can be produced on a square kilometer scale that you need for solar energy really to contribute to the energy supply of the world. To get all the steps right all the time is what takes so much time and what makes this such a long process. And there's always some step which is harder than you think beforehand.
cooperation is a key topic in our research and also a lot of fun. We have a lot of cooperations in the Berlin area with all the universities. We have cooperations in Germany with many institutes, universities, also with industry, and also in Europe and going all over the world.
Creativity is very important. You need to be creative, and you also need a strong wish to be creative.
This is not a standard procedure. The atoms somehow don't listen to you. You tell them to do that and they do something else. It's a bunch of children, and you have to somehow seduce them to do something that they normally would never do.
There's so many reasons that you can think of why it would not work. That if you don't have this vision and you don't think big, you will never succeed. So that's also our job as scientists, to be optimistic. Just 10,000 more of these small puzzles to go and we have the solution.